So when you picture the edge of our solar system, what comes to mind? You probably think of the last planet, Neptune, maybe Pluto, and then just black, empty space, right? Well, what if that whole picture is completely wrong? Today, we're taking a journey to the real edge of our cosmic neighborhood. And trust me, it is way stranger, way more violent, and a whole lot more mysterious than you ever imagined. Yeah, what if there's no clean line in the sand? Instead of just stopping, imagine a series of vast, overlapping frontiers. We're talking about regions filled with debris, invisible force fields, and even shocking walls of superheated gas. That's the reality we're going to explore. Okay, so our journey really kicks off where the familiar map just ends. We're heading way out past Neptune's orbit. We're leaving behind that neat, orderly world of planets and venturing into the wild, untamed frontier of the outer solar system. Look, let's just get this out of the way. That old model we all saw in textbooks, that simple, clean edge, it just doesn't exist. The reality is this incredibly complex, multi-layered, dynamic boundary that honestly, we're only just now beginning to truly understand. First up, we run into the cosmic leftovers. And I'm not talking about a few stray asteroids here. No. These are two immense structures, giant rings and shells of icy bodies that hold the very building blocks of our solar system frozen in time for billions of years. The first of these is the Kuiper Belt. The best way to think of it is like a giant cosmic junkyard, a massive donut of ice and rock that starts right after Neptune. But, instead of old junk, it's packed with these primordial objects, the raw materials that never quite managed to form a full-blown planet. Now, you've definitely heard of the asteroid belt, right? The one between Mars and Jupiter? Well, the Kuiper Belt is on a whole other level. It's not just farther away, it's vastly larger. And it's filled with all sorts of exotic, icy stuff instead of just boring old rock. This is where the solar system starts to get really, really big. And when I say the scale is staggering, I mean it. We've officially cataloged over 2,000 objects in the Kuiper Belt. But get this, that's like the tiniest fraction. Scientists figure there could be hundreds of thousands of objects bigger than 100 kilometers across, and literally millions of smaller ones, all just silently orbiting out there in the dark. And the coolest part? We've actually been there. Well, our robotic ambassador has. NASA's New Horizons mission gave us our first jaw-dropping close-ups. It showed us Pluto wasn't just some boring dead ice ball, it's a complex world with huge mountains made of water ice. And then it flew by this bizarre object called Orokath, which looks kinda like two pancakes stuck together, a true untouched relic from the dawn of our solar system. But believe it or not, the debris fields don't stop there. Way beyond the flat disk of the Kuiper Belt lies something even bigger, the Oort Cloud. Now, this isn't a belt, it's a colossal, spherical shell that surrounds our entire solar system. It's like a giant cosmic snow globe, and we are literally inside of it right now. Now, we've never actually seen an object in the Oort Cloud. It's just too far away, but we see the evidence it sends our way. It's thought to hold trillions of icy bodies, and every once in a while, a little gravitational nudge from a passing star sends one of them hurtling towards the sun, and that's how we get those spectacular long-period comets, like Hale-Bopp. Okay, so we've made it past the rubble, these giant fields of ice and rock, but the next boundary, well, it's not made of anything solid at all. It's a bubble of pure force, an invisible shield that protects everything inside, including us. This incredible shield is called the Heliosphere. You can think of it as this giant magnetic bubble being constantly inflated by the solar wind, that stream of particles always flowing out from the sun. This bubble is so important because it pushes back against the stuff between the stars, shielding Earth and all the planets from a ton of dangerous galactic radiation. Without it, life here might not even be possible. But this bubble isn't just one simple layer. It's more complicated than that. As you travel outward, you first hit the termination shock, where that solar wind suddenly slams on the brakes. Then you enter this turbulent, chaotic region called the heliosheath, where the wind piles up. And finally, you reach the heliopause, the ultimate edge of the sun's influence, where interstellar space truly begins. And you know what's amazing? This isn't just theory. We know this stuff is real because we have been there. The legendary Voyager spacecraft have actually crossed this boundary, and the data they sent back from that crazy middle zone, the heliosheath, man, it was nothing short of shocking. Seriously, try to put yourself in the shoes of a scientist back then. You're watching data trickle in from a probe that's billions and billions of miles away. For decades, it's been pretty predictable. And then, all of a sudden, as it enters the heliosheath, the numbers start to go haywire. Something really weird is happening out there. It wasn't just one thing. First, the solar wind pressure starts climbing. Then, the magnetic field lines begin to twist and contort. And then, the turbulence just spikes, totally off the charts. The probe was flying through a region unlike anything it had ever encountered before. It really captures the sheer intensity of what Voyager was flying through. Now, it wasn't a wall you could see, of course, but it was a boundary of superheated, compressed plasma so extreme that scientists gave it this incredible name. They called it the Wall of Fire. And how extreme are we talking? Well, temperatures in this region were measured at somewhere between 30,000 and 50,000 Kelvin. To put that in perspective for you, that is up to 10 times hotter than the surface of our own sun. An invisible wall of superheated gas at the very edge of our solar system. But just when you think it can't get any weirder than a wall of fire, the universe throws another curveball. As we started to map this whole boundary region, we stumbled upon one last profound puzzle. Something that was supposed to be there simply wasn't. See, for decades, scientists just assumed that as our whole solar system barrels through the galaxy, it should create something called a bow shock. It's the exact same idea as a speedboat plowing through water, right? It creates that V-shaped wake in front of it, a violent pileup of gas and dust. Every single model predicted it. We see them around other stars. This final, dramatic wavefront should have been marking our passage through the cosmos. But when NASA's IBEX spacecraft finally got a good look at the region where it should be, it found nothing. The bow shock was missing. And it turns out, our whole idea of this violent collision was just wrong. Instead of a sharp, powerful bow shock, our solar system creates a much softer, gentler bow wave. Basically, our boat isn't moving fast enough to break the water, so to speak. And why does this matter? Well, it tells us something really fundamental about our place in the galaxy. Our sun is moving at about 52,000 miles per hour, which sounds incredibly fast to us, but in cosmic terms, it means our interaction with the local interstellar cloud is surprisingly gentle. We live in a calmer corner of the galaxy than we previously thought. So from icy junkyards and cosmic snow globes to invisible firewalls and missing shockwaves, the true edge of our solar system is a place of constant discovery. It's this amazing reminder that no matter how much we learn, the universe always has another surprise waiting just beyond the edge of the map. The only question is, what will we find out there next?